Hello there, this is Vulture, and today I would like to show you this real clock that I'm building. It keeps real time using the new time code blocks. This says, look, 9:47, and that says it's 9:47. So here we are in a world where I've just stripped out the moving parts and the script that runs it. I won't go into building the building. You can build it however you like. But one neat trick is to use a text object for Windows. This is a lot lower capacity than bringing in a whole bunch of other rectangles. And so what you do is you bring out a text object, and these are just letter I's. And I thought the ones that looked the most like Windows was the Anton SDF font. So this is an HTML open tag. Font equals Anton SDF. You can get more information on that with the new gizmo. So it's the text formatting asset here in the community spotlight section of your library. You can spawn one of those out, and it gives you a nice little reference tool about all the fonts and other text tricks you have available for you in Horizon Worlds. So again, I made the font tag, and then I put I space I space I, and then I put in the HTML tag for line break, and then I space I for the next row of windows, and so on and so forth until I completely made one side of the building. So the way you make a clock hand is get out a cylinder and a cone, size them the same size, and put them together with your snapping tool on. And once you decide that's the size you want, duplicate the whole thing, selecting the arm first. Duplicate it, and then just turn it 180 degrees on its axis. I'm going to go back to the hand, and I'm going to move it down, and I'm going to snap it up into position right next to it. So now with all of these grouped together, you see that we'll be able to script a swinging watch hand. But before I do that, I'm going to select this and this, open up their group properties, and I want to make them invisible. Now I'm going to select everything together, put it into one group. So now I have one swinging watch or clock hand. The other tip I have is that unless someone's actually going to be touching this thing, make sure to go into the group properties and make it non-collidable. That's going to help you save on object capacity. So what I did was I just duplicated this group over here and made it a little bit smaller to be the hour hand. And this thing here, this is just the middle part of the clock that everything's going to circulate around. So you can just move them all together to have your watch and minute hands. And then they will swing separately like that. Okay, so now that we have that built, we're going to pull out a script, and we're going to give it a name. We're going to call it clock hand. And for now, we're just going to start with, can I not spell clock hand? Clock hand. Now we're just going to start with two variables because the script is going to be attached to each of these. And I want to tell the script whether or not the object is an hour hand. So it's going to be a Boolean. Boolean of true and false. So that will be passed in by these. So for instance, let's separate these. This is my we're going to attach him the clock hand. Minute hand is obviously not an hour hand, so that's false. The hour hand, and he gets attached he obviously is an hour hand. So we're passing these parameters into the script. We're going to set another variable over here that where we're defining seconds. So it's going to be an integer. The script is running on default, by the way, and it says when the world is started, we're going to be doing a couple things here. If we're an hour hand or if we're not an hour hand. So if we're an hour hand, we're going to do something. We're going to set seconds. And if we're not an hour hand, set seconds to something else. And the reason why we're setting these variables like this on start is because the clock face is basically, it's a 12-hour clock, even though there's 24 hours in a day, but we're only concerned with 12 hours. So if the hour hand has to make a revolution every 43,200 seconds, that's how many seconds there are in 12 hours. A minute hand, the longer hand, has to make a revolution around the clock face every 3,600 seconds. That's how many seconds there are in 1 hour. Now that that's set, the first thing that we want to do when somebody first loads the world, the first person who comes into the world, is we want to set the clock face to read whatever the present time is. So initially, the rotation of both of these hands should be straight up. So what we're concerned with is manipulating the X rotation of these. Once I find out what the hour is, I'm going to change the X value of the hour hand to something 0, 180. I don't care about Y and Z, I just care about the X. And the same for the minute hand. So what this means is that when the world is started, we're not just setting the seconds, which we need later, but we want to rotate self by something 0, 0. So we need to figure out what that X value has to be. And the way we're going to do that, here under vector math, we're going to get this command, new rotation from X, Y, Z. And into the Y and the Z, we're going to just put a bunch of zeros because we're not changing those. All we're doing is changing the X. So what is the X? So let's talk about setting the minutes first because that's a little more straightforward. So we're going to get our times operator here. And then into the left side, we're going to put a division thing. And I'm just going to grab some numbers here. When I say 360 degrees divided by 60 minutes times minutes. So this gives us the degrees around the circle that represent 1 minute, and then we're going to times it times however many minutes it should advance. So now the question is, how many minutes should it advance? That's when we come over here to the operators tab, and we come down and we grab our brand new command, current date and time, and we say the current minutes. So this will return some number like 5. 360 degrees divided by 60 minutes times 5 minutes. And then the minute hand will rotate directly to that. Okay, so that takes care of the minute hand. You can see it's now 10:25, and I got this facing down to the 25. Hours are a little bit more complicated. The first problem, you would think you could just do it like we did with minutes. You just divide the clock up into 12 equal slices because it's a 12-hour clock, and then times it times the current date and hour. Well, you could see, now I just put that in here, and it's pointing somewhere over here on the right. And that's because this thing is not returning my current time zone. It's returning the time zone of wherever the server is right now. So I calculated that the time zone difference is I'm behind 4 hours from where the server is. So I'm going to create another variable over here. We're going to call it time zone offset. And I want to subtract 4 hours from wherever the thing is. So it's not just the current date and hour. It's going to be the current date and time hours minus my time zone offset. So let's give that a try. So that's looking better here. This is pointing more or less at the 10 and then going to the 25. There's still another issue though, is that if it's 10:25, you can see an hour hand is not pointed precisely at the 10. It's somewhere between it. So we need to not just divide up the clock by 12 times it times wherever we are in hours, but then we need to add in a fractional degrees for however far through the hour we are in minutes. So we need to calculate what is the minute fractional. That's going to be another number. So I'm just going to do that calculation in a variable. Set minute fractional to something times the current minutes. And what that's going to be is, I want to get another division over here, and then I'm going to put another division inside of that one. And so what I'm going to say is we're going to take our 360 degrees of the clock, divide it into 12 equal sections, and then we're going to divide that little 5-minute wedge into 60 equal slices. And then we're going to times that times whatever the current minute is. So it's going to be this one, it could be 1/60th of 1/12 of the pi. And then we're going to add that to here. So the way I like to do this, I'm just going to duplicate this over here. I'm going to get rid of all this stuff. And then we're going to say plus the minute fractional. And then all of this stuff that we did earlier, if I can grab the right one, is going to go into here. And then we're going to delete the old code block there. So rotate self by a new rotation of 360 degrees divided by 12 times the current hours minus the time zone offset. That's that first section there. And then we're going to add in the minute fractional, which is 360 divided by 12 divided by 60 times however current minutes are. And so all of that together should rotate the clock to where it should be. And it looks like it does. 10:32. Let me double check that. That looks totally wrong. Oh, this stuff drives me nuts. That's when I think, oh, the rotation's backward on that. It probably is. What if I told this thing to start off 180 degrees different from where it is? Why are you cooperating with me? 180. All right, so now let's run the script. It's totally wrong. Oh, here, that's why it's wrong. I got to tell it's an hour hand. There it is. Look. 10:32. Woohoo. All right. So now we are, as they say, cooking with grease. Okay. Oh, just the act of moving that made that thing not work. Okay. Now I'm going to go shoot myself. And that's correct. 10:35. There we are. Okay, so now step number 2. We have set the clock through all this crazy stuff. Now we're going to tell it to rotate in real time. So we're going to send an event to ourselves. Set event to object. Make sure you get it completely outside of that green. There we go. And we're going to send the event rotate to self. And is received, we're going to rotate self by this stuff again. And the reason we're saying by again instead of rotate to is because, especially on a clock like this, I got 4 faces to this thing. And if I said rotate to, it would be going to the absolute world coordinates. And I really want it to rotate by local rotational vectors. So it's going to rotate itself by something, and then it's going to send the loop back to itself on a delay, which has to do with the seconds. Now, in a rotation event, I have found that I can't just say rotate self by 360 degrees. If it will let me write it in there. No. For some reason, it'll go backward. It may go backwards. So I like to divide rotation events into 2 events. First rotate at 180 degrees, then send the second rotation event back to itself to go through the second half of the circle. So we're going to say 180 degrees. So we're going to do that over a time period. You can't just rotate it by 180 degrees. So we're going to go back to here because I got the wrong one. We're going to rotate by over seconds, and since we're doing it halfway, we're going to say seconds divided by 2. So I'm going to get a divisor operator in there. Let's see, I'm going to grab a number, and we're going to say however many seconds we're supposed to go by divided by 2. And remember, we set seconds up here. So however many seconds are in either 12 hours or in 1 hour, that's how much I want it to rotate by. Over those seconds, half of that, it should go halfway around the clock. And then it's going to send that event back to itself over the same period of time. So by itself, this should work when we set the world. Now, I could sit here to debug it. I could sit here and look at it for 12 hours, and that's going to take a really long time. So what can we do to speed it up? So what I'm going to do is I'm going to divide up that time a little bit to make it go faster. I'm just going to create a new variable and call it divisor. And I'm going to say rotate this over something seconds divided by the divisor. And I'm just going to make it really go, blazing fast. We're going to chop up that time by a factor of 80. And I'm going to move that into there. And I'm going to do the same thing to my rotational event, right? So I'm going to do that. So you can see it's working, but we are in the upside down, and the clock is going backward. This one's going forward. So I discovered the same issue when I was working over here, and the way I got around that and say, instead of going 180 degrees, let's go a negative 180 degrees. And then we hit play. Now everything is going forward. And if I keep watching it, the hour hand is going to go forward too. So I'm going to make this divisor go even faster. Let's go to 300. And then restart the world. ain't working at all. So I just hit reset a few times, and now everything's going in the way that it should. Minute hand's going clockwise, hour hand is going clockwise. And once I'm sure everything is working as it should, I can sort of, the visor, this is just for debugging purposes, I can change that back to 1. So now when I reset the world, my clock hands will go in real time. We can sit here and watch the grass grow, just like we do over here. I kind of like this because as I'm working, I could just glance up at my skyscraper and my clock tower at any time to see if dinner's ready upstairs. Because I can't cook. I do the dishes. I don't cook. Anyway, the only other thing I want to point out on this is if you're watching some of the other tutorials about the current date and time block, you'll know that the hour, the current date and time hour, this is not returning a number between 0 and 12. It's returning a number between 0 and 24. However, this still works because even if this number is above 12, it still works out fractionally, the math correctly. So I could rotate the self by 13 times around the clock or 14 times around the clock and then subtract my time zone. Or it'll be 0 if it were up at 12 minus 4, and then it still ends up where it's supposed to. Or at least that's been my experience so far. Anyway, I hope this was helpful to you guys. As you can see, sometimes programming, there's a lot of trial and error and there's a little bit of frustration. But if you stay patient, you will solve your problems. If you'd like to have a copy of this clock asset that we made together, please leave me a comment and I will be happy to share it with you. Otherwise, I hope you'll give it a try making it on your own. Bye.